Okay, in this first video, we are going to talk about something called a parametric equation. So the three objectives are to be able to eliminate the parameter, to be able to find parametric equations for a line, and then actually the third objective, I believe I'll do in a separate video, be able to do word problems with parametric equations. Let's get started by seeing what a parametric curve or parametric equation is. It is two equations given in terms of a third variable. So what this is going to do is it's going to open up our options in terms of how we think about things. So you have two equations here, x equals something, and then y equals something, where t is considered the parameter. So it's a third variable that are in both equations. Okay? So let's look at an example of how we can graph these types of situations. So for the given parametric interval, graph the parametric equations, x equals t squared minus 2 and y equals 3t. Okay, so you can make basically a t table of 3 columns. I'm going to say, okay, let's look at 1t is negative 3, negative 2, negative 1, 0, 1, 2, 3. So what I would do is I'd plug in negative 3 for just the x equation. Negative 3 squared, which is 9, 9 minus 2 is 7. I'm going to do all my x equations first. I'm going to fill my x column. Negative 2 squared is 4, minus 2 is 2. Negative 1 squared is 1, minus 2 is negative 1. 0 squared is 0, minus 2 is negative 2. 1 squared minus 2 is negative 1. 2 squared minus 2 is 2, and 7. So those are my x values, but then I take those same t variables and plug it in for the t in the y equation. So I have a 3 times negative 3 is negative 9, 3 times negative 2 is negative 6, 3 times negative 1 is negative 3, 3 times 0 is 0, so on and so forth. So I end up with this table. And what this allows me to do is to graph the parametric based on this table. So now when I go to graph, I'm just going to use the x and y column and plot those points. Okay, so it looks like my x's get as big as 7, and go back to negative 2. So I got to live in my axes, and then these go up to 9 and down to 9. Values. Okay, so I have the point 7, negative 9, which is down here. 2, negative 6. Negative 1, negative 3. Negative 2, 0. Negative 1, positive 3. Positive 2, positive 6. And 7, positive 9. I actually draw these points. Or draw the curve through these points. You can see I ended up with a sideways facing parabola. You can see how we can have a system of equations, a pair of equations written with that third parameter, and we end up with shapes that we've already seen. Here's just another slide to show you that if we change those t values, we plugged in on the table, and the last one I went from negative 3 to 3, so you can see that that is the picture we got. But if you limit the t's that you plug in, for example, if we only go from negative 3 to 1, you would end up with just a portion of that curve. And if we went from negative 2 to 3, you'll see that we have the top part, but it stops early here. So it is important to make sure that you have enough t values to plug in to make sure you get the full picture that you just saw. Okay, so the first thing we have to be able to do is be able to graph these parametric equations, and we would do that by making a table. Second thing we have to be able to do is this thing called eliminate parameters. Remember, the parameter is the t. So virtually we just want to get rid of the t, and we're going to do that algebraically. So we're going to use the idea of substitution. You can choose either equation and solve it for t. In this case, I'm going to take the x equation, because to solve that for t, I would just subtract both sides, and I get that t equals x minus 1. Now that we have a value of t, we can use that and replace the t in the second equation with the x minus 1. And what this does for us is it turns us back into an equation that we're used to dealing with. So you can see where if I distribute, I get y equals 2x minus 2. And hopefully we can look at that and say, okay, this is going to be a line with y-intercept, that's this last part, 0, -2, and finally with a slope of 2. That's the first 2. I could graph it if I want. For y-intercept of -2, rise 2, run 1. And there's a picture of this parametric equation. I was able to graph it quicker because I know what that looks like. So this is another skill we'll want to use. Sometimes they're as basic as this. Sometimes they get a little more complex. Obviously, because this one has a square and this one has a the same process. Pick one of the equations to solve for t. In this case, I decided to say that t equals y over 6 because I didn't want to deal with the square. I take that and I substitute it into the other equation, 5 minus y over 6 squared. When I simplify that, I get x equals 5 minus y squared over 36. Remember, we have to square the top and bottom. And subtract 5 from both sides. X minus 5 equals negative y squared over 36. Next, I multiplied by negative 36 on both sides. Out. 36. So currently, y squared equals negative 36 times x minus 5. Last but not least, to get rid of the squares, we square root. But it's important to know when we do square root, we end up with plus or minus square root negative 36 times x minus 5. So when you do have a y equals a square root, it is a parabola. A parabola that opens to the left, though, so it's that sideways facing parabola. It's going to open left because of this negative that reflects it left and right. This goes back to some of our graphing ideas. So it's going to be a parabola. Again, the first one we saw faced this way, but as soon as you have that negative there, it's called this. So it's not this, it's this way. Open left. And then again, we should be able to remember that this minus 5 would actually shift it 5 to the right. So it would be with vertex 5, 0. And when all is said and done, I'm not going to make you do some of these more advanced ideas, but the last one where it was a line, you'd have to be able to recognize that. We'll also get into some circles later this chapter. Okay, so pause the video now. I want you to go to your guided practice and try number 7. Based on what we just did, but please note in your guided practice it's x equals t squared minus 4t. I want you to delete the second t. Y equals t minus 1. So pause the video and then come back. Check your answer. So I chose to solve the first one for t, or the y value equation, I should say. I got t equals y plus 1, so I plugged that into my x equation, y plus 1 squared minus 4. I did use the solve this algebraically, and what I did is I added 4, I got x plus 4, equals y plus 1 squared. Again, square root, derivative square, I square root both sides, gives me plus or minus square root of x plus 4, that's now equal to y plus 1, subtract 1. My final equation would be y equals negative 1 plus or minus square root of x plus 4. Now I know the square root graph looks like this, and this would be back in the last one. Plus or minus means it's upside down as well. So it is a parabola. There's no negative under the radical, so it's open right. Last but not least, the vertex, which usually starts at 0, 0, moves 4 left. It's the opposite of that one. To be negative 4, and then this minus 1 means it shifts down 1, so or negative 1. Now you could make a t-chart and graph it as well if you didn't know some of those rules. Okay, so now that we've practiced that, we're going to look at one more in this part of the lesson. And that is, what if you get something that looks like this? Eliminating the parameter, so same directions as the last one, except when we look at it, we see x equals 3 cosine t, y equals 3 sine t. The strategy I've been using so far where I choose 1 to solve for t isn't going to work as well. This is where it gets a little more complex, and so we have to actually think about what else we know. As soon as I start seeing sines and cosines, the thing that's going to come back into my head is a relationship between these two things. Sine squared plus cosine squared equals, and hopefully the number 1 is popping in your mind. The reason I say that is because this is going to be a unique way where we do something to try to get sine squared plus cosine squared, because then we're able to change it to number 1. So let's look at what I mean by that. So if I wanted to get this to be cosine squared, I need to square it. If I wanted this to be sine squared, I need to square it. And I need to be adding them together. So that's exactly what I'm going to do. I'm going to take the x and square it, and add it to the y equation and square it. And that's going to give me 3 cosine t squared plus 3 sine t squared. So this is the other option we will have to use to eliminate the parameter. And I'm going to show you how this works out for us. We keep the x squared plus y squared, so I put the equation. I distribute this. I get 9 cosine squared t plus 9 sine squared t. Now we can see on the right hand side, I can factor out. Then 9, so I get 9 times cosine squared t plus sine squared t. And this is how I eliminate the parameter. I can use this identity now and say that x squared plus y squared equals 9 times 1. So x squared plus y squared equals 9. That is my formula. Okay, and again, I've eliminated the parameter because there's no t's in it. Now, hopefully you remember back from what we did at the beginning of the year, the circle equation is x minus h squared plus y minus k squared equals r squared. You are going to see this at times. So this picture is going to be a circle. Its center, in this case, 0, 0. We are going to identify some of these two things. And the radius will be the square root of 9, which is 3. Okay, last but not least, I want you to try guided practice number 8, again with some, first of all, cross off number 9. We're not going to do guided practice 9. And then you have to make somewhat of a change to number 8. It should just read x equals 4 cosine theta, y equals 4 sine theta. Let's scribble up the 3 plus and the 2 plus and change the 6 to 4. Pause the video, try it. Exactly what we did in the last one. Review both things and add them together. Oops, this should be on the outside. I get x squared plus y squared equals 16 cosine squared theta plus 16 sine squared theta. I can factor out the 16. Cosine squared plus sine squared. That's a 1. So I get x squared plus y squared. Once again, I'm going to bring a circle. This color is 0, 0. And radius is the square. Okay, before we move on to the next lesson, I do want you to go to, we'll come back and make a different video on this, assignment number 3. It's going to be worksheet B. You're going to do numbers 1 through 11 eventually. Again, you'll want to watch the applications video first. But I want you to cross off numbers 6 and 7. Those will be similar to what we did, but more complex. And I need you to make this change to 5. So 5, 6, and 7 are what we just worked on, except they're too complex. So cross off 6 and 7 and change number 5 to x equals 5 cosine t, y equals 5 sine t. So you'd be able to get through about that many problems. You can do number 5, and then you'll want to come back and do the rest of the worksheet after you do the word problems. Thanks.